Brett, I'd really like to thank you and the members of the Space Commission, and we're looking for great things from the Commission. So, and the members will be around, so take a chance to talk to them. For our next panel, we're going to talk about an industry that has already been noted as really a major part of Arizona's economy. This is the rapid expansion of the semiconductor capabilities and infrastructure here in Arizona. And it's really exciting to hear about this growth and how it can benefit our thriving space industries. There's a major skilled workforce here in Arizona, reliable supply chain in place, and opportunities to innovate in critical areas, radiation-hardened components, particularly high reliability devices, power systems, communications, sensing, and MEMS. With this session, we're going to explore how these high-tech growth industries in Arizona can come together, accelerate impact, and particularly how it can help the space area. So with no further ado, let me introduce or welcome the semiconductor panel. Thank you.
Good morning. It's my pleasure to welcome you to today's panel discussion on strengthening ties, how Arizona's space and semiconductor industries can collaborate for economic growth. Arizona stands at the forefront of innovation with its thriving space and semiconductor sectors driving significant advancements and economic growth. Our state is home to cutting-edge research institutions, leading technology companies, and a highly skilled workforce, all of which contribute to our position as a hub for technological progress. Today we will explore the synergies between these two dynamic industries, the semiconductor sector and the space sector, and how these two high-growth industries in Arizona can work together to accelerate their impact. Now I'd like to introduce myself. I am Janick, the Chief Technology Officer at Benchmark Electronics, headquartered here in Tempe, Arizona. Benchmark is a design and manufacturing services company with experience in supporting the space industry. We have technology that we have designed and manufactured on the Europa Clipper, for example. Benchmark is located at the intersection of semiconductor and space industry, with more than 25% of our revenue coming from the semiconductor capital equipment sector, but also supporting nearly every satellite communications major logos. I look forward to a stimulating discussion and the valuable perspectives our panelists will bring. Thank you for joining us today. Let's meet our panelists. Let's start with you, Christine.
All right, good morning, everyone. Christine Boles. I am with Intel, and specifically I'm a part of Intel's Edge Computing Group, where I lead our Federal and Industrial Solutions Division. And specifically, that is where we look at how do we apply the range of technologies and products we have to a plethora of industries, from retail to communications to where I focus, federal and manufacturing types of applications, space being an opportunity as well.
Hi, I'm Grant Anderson. I'm the president and CEO and co-founder of Paragon Space Development Corporation. We're a 32-year-old company down in Tucson, Arizona. Been in the space business for, it'll be 40 years this year, which is shocking to me. And Paragon does life support in extreme environments, and space being the ultimate extreme environment. It's about 80% of our business, but we also do, warfighter protection and stuff like that. When you got bullets flying at you, that's also an extreme environment. But and we're been at the forefront of pretty much every single human spaceflight program in the last 20 years in the United States.
Thank you.
Good morning, everybody. I'm Michael Rosas. I am VP of Business Development at the Arizona Commerce Authority. The Arizona Commerce Authority is the state's economic development arm. So think of it as the Department of Commerce. And my focus, amongst many others, is the semiconductor industry. So excited to talk a little bit of that today.
So my name is Hugh Barnaby. I'm the resident faculty here from Arizona State, although I was at University of Arizona for a couple years, so before I came up here. But I've been up here for 20 years. I'm an electrical engineering professor. We specialize in my group in microelectronics for extreme environments. But we're also, of course, have the swap hub, which was alluded to earlier, and that's a big part of what we're doing right now, as well as the SHIELD program. So between packaging, we also have a major extreme environment testing and analysis component. So I think that's one of the things we'll be talking about.
Thank you. Okay, Michael, let's start with you. Arizona has seen remarkable growth in its semiconductor industry. What strategies and lessons learned from ACA's success in attracting and supporting semiconductor companies can be applied to boost the commercial space sector in the state?
Thanks for that. Well, Arizona has a strong history in the semiconductor industry. Some of the recent success in the last 4 or 5 years that we've seen has been the result of a lot of strategic planning. Lisa was alluding to it earlier, but there has been a very long-term vision, a lot of private and industry collaboration that goes on here. So it starts with building an ecosystem, right, that ensures that industries have the workforce, infrastructure, and business environments they need to thrive. Partnering with industry, academia, and policymakers to align resources and drive innovation, and then creating competitive advantages through policies and incentive programs to make Arizona the best place to start, grow, invest, and expand. So by that, you know, for one example is the National Semiconductor Economic Roadmap. So this was something, it's an initiative that started by the ACA at the time, but it was really, we took a good look at the industry of semiconductors and said, all right, there's this going on in this state, this going on, but there was nobody that said, well, this is what we need to collectively do to bring onshoring back to the United States. So although it was driven by the ACA, it was industry-led. It was industry telling us what needed to happen to get to that next level. And so it was from across the entire nation, from industry leaders saying, hey, well, there's this focus needed. And so by that, we were able to really zone in on where we were at now, where we wanted to be, and what needs to happen over the next 5 to 10 years. And again, this is right to Lisa's point earlier, where she said, you know, there's such a big spread in this industry. You need to really focus on what you're going to be good at, and then identify that, and then build on that, right? And so the model there is already driving growth in other key sectors, including aerospace, right? So Arizona is already #1 in the nation for concentration of guided missiles, space vehicle manufacturing, and top 5 in A&D manufacturing and employment. So in just the past few years, we've seen Black Star Orbital grow here, Blue Origin, Virgin Galactic, Honeywell, Northrop. And a lot of this, again, is because of that, the fact that we have the workforce here, but it's a very concentrated effort for that.
Thank you.
Can I add to
sure.
that, Jan? So particularly for the companies in the room, and Lisa touched on this, a company like Intel being in the Valley, we spend a lot of our time making sure that we are in partnership with groups like ACA, Arizona Tech Council, the various chambers in the area to make sure we're doing the very deliberate plan of workforce development, how the infrastructure to support, what is the overall incentives to bring our supply chain along. So it also is a partnership. It's, you know, with the companies in the Valley and or in the state to bring the right capabilities in. And it's a very deliberate strategy.
Thank you. So Christine and Grant, both Intel and Paragon work with advanced materials and manufacturing processes and electronics that must meet rigorous quality standards. What potential synergies do you see between companies like yours that could drive innovation in both the space and semiconductor industries?
So twofold. One is, of course, what products we both build. Space industry needs compute. And semiconductor companies, what do you provide? You provide a lot of the compute and or ancillary components that are needed. So understanding the industry's specific needs is what we have to understand as one industry serving to another, such that we have the right products. So that's kind of foundational. But I think there's also, and Arizona being such a hub for advanced manufacturing, and the opportunity for us, and there are communities that we can do this together in, but specific to the space industry, how do you bring the right folks together to share some of those BCAMs, benchmark, what are some of the advancements? Semiconductor is a very advanced manufacturing. Space industry has very specific requirements, and there's opportunities for us to collectively look at what are we doing in one industry and how can you bring those capabilities in. And it comes through working together and benchmarking. And not benchmark as in Jan's benchmark.
Yes, thank you for the plug.
Yeah, one thing that's interesting about our two industries is she has to figure out how to make a million things a day that all work exactly right. I have to figure out how to make 2 things a year that work exactly right. But I will say one thing, I'm really dissing the space industry here. We are way behind electronics because the conservatism associated with what we fly. I remember when I worked at Lockheed back in the 1980s, they were bragging about launching a 286 chip in 1990. It was the 3 generations behind, and so we need to close that gap and really be using the best advanced electronics in what we do. One of the most expensive things I can build, like our Urim processor that's up on space station right now. The actual mechanics of the Urim processing and doing it was about a $10 million project. The computer that controlled it was $4.5 million. It was another 50% on things. And there's no reason why it should be that way, other than we're forced to choose class 1 parts, what we used to be called JNS parts, that frankly I don't think do us any good, other than make it more expensive, longer lead times, and we end up flying things that are 2 to 3 generations behind. So working with Intel to try to figure out how can we shorten that and get to the point where we're actually state of the art in electronics up there.
Yeah, Grant and I share a very similar view of that. How do you use, we call it off-the-shelf products, but specifically what technologies, they apply ubiquitously to a range of applications, but they're used specialized. And really, how do you take that volume that exists from other industries and then utilize it in the specialized needs? That's the opportunity.
Thank you. Hugh, with the
Can I comment a little bit
Sure.
on? Yeah, this is a business that I know pretty well. So we do a lot of COTS. I mean, so we do extreme environment characterization. I've been doing this for 30 years, and the cost of the components is legacy, and that's why you go back so far. Clearly, working with groups like Intel or Global Foundries or TSMC and getting those more advanced technologies out there is very important and very doable. In fact, we work on several of the really advanced CMOS technologies right now. And the packaging is a big part of that. So we've got packaging coming up here because, and Sandia Labs is very good at this. And so they're part of the swap hub. And so the idea here is to try to have targeted, very rad hard, extreme environment technologies in one component, one area, and then integrate those with very advanced chips, and then put them together with the packaging strategies. So there is a path forward to make this work. You'll never be able to get past the testing, though. You have to do your testing, but there are cheaper ways of doing that, I would agree, for sure. So that's my comment on that.
Thanks, Hugh. Maybe you can follow up a little bit more on the CHIPS Act funded national facility for semiconductor advanced packaging at ASU. I think you mentioned it as the swap hub, and how that can help the collaboration between the space.
So Sally brought up the 3 real components. So number 1 was the CHIPS Act Microelectronics Commons swap hub. And so that is a prototype facility which exists in Tempe. It's in the main well, it has over 120 partners. Intel is part of it. I think if you're not a part of it, it doesn't really offer anything right away, but it does help to facilitate conversations. So you can find that online. And that's the first one, and that's a prototyping facility where we're making, one of the things that we're doing right now is starting to make structures that would be a representative of the types of things that that you see in integrated circuits, but it's a lot cheaper. We can make wafers for $5,000, so we can do certain things that are helpful there. Obviously, for those type of prototyping things, we have to work with the industries to figure out what their needs are. That's really important. So Intel, Paragon, all you guys, we need to know what it is that you're concerned about. We might be able to do some things to tell you about those concerns. Another thing, of course, that's big in the SWAP Hub as well as the SHIELD program is now a big packaging center. Packaging is a huge component here because it allows you to integrate so many different technologies together, because we're not just dealing with chips anymore. We're dealing with, the microelectronics industry had scaling. Now the scaling is done by putting these things together, very complex integration strategies. So those are the types of things that that SHIELD program is going to be able to facilitate, as well as the SWAP Hub. And in addition to that is the NatCast Center, the Technology Center, which is also primarily focused on packaging. All of those are very serious resources that exist in Arizona right down the street. So if you're not engaging with that, please come talk to me, and then I can put you in contact with the folks that you can engage with, because that is a big, big deal right now. So.
Thank you.
Can I touch on that one too?
Sure.
I just want to say that because I get very excited about the NatCast project. That one is just big for Arizona. It really sends the message that this NatCast and ASU partnership is a complete game changer, right? It sends the message that we're not only a semiconductor hub, but the semiconductor renaissance is happening here in Arizona, right? That means that this facility, when open and running, is going to be running a full line of advanced packaging, prototyping, testing, which is going to allow us to build, and this is not just the one silo semiconductor, right? It's going to build the very next level, most advanced chips for quantum computing, the ones that are going to be in the rockets. But this facility is the exclamation point at the end of the sentence, right? What happened all these years beforehand was, again, to the panelists before here, where they were talking about there's a lot less sexy headlines of manufacturers of cables, right, of optics, that all had to be here first in order for TSMC or those type of companies to say, you know what, yeah, we're going to come here because some of our suppliers are here and we can bring the rest. And then that's where the partnerships come in to help bring the rest of the suppliers here. But this facility, one of the main proponents for choosing work, because it was a very competitive national search for this, was the ecosystem, where they were looking for the ecosystem that made sense for them to be successful from the start. And again, you cannot, somebody was talking about the incentives piece earlier, whether Arizona stands at a deficit versus a Texas or Florida or New York. You cannot buy relevance. So if you make an ecosystem here where you have the workforce needed, where you have the infrastructure and a business-friendly environment, and you build that, you become relevant to the biggest manufacturers and the next level technology. So the next big breakthrough in semiconductor will be happening here in Arizona, and a lot of people still don't see Arizona as the most advanced facility in the world is going to be right up the street here. So.
Yeah, and I'll build on Michael's point, and I don't see Lisa in the audience, but Lisa made the point of the Space Coast. This could be the space desert, similar to what happened, Silicon Valley. This is the Silicon Desert because of the years of history that we've had, and now the bigger additional companies are coming into the valley.
Thank you. So, Grant, both you and Paragon have a long history in developing systems for space. How has the space industry changed over the years, and what are some of the new challenges that the space industry faces?
Oh, wow. Yeah, everything's changed. I often joke that I started the company about 20 years too early. But it's not true. You know, if we're at New Space 2.0 right now, Paragon started New Space minus 2.0 and kind of worked forward. No, you know, when we started the company, there really wasn't even a market for what I did. The life support systems were done sort of as a peripheral business of either Garrett or Honeywell or Hamilton Sunstrand. There was nobody who was really concentrating on it. We realized that if you can't launch a human to space without a life support system, and it's a perpetual thing, we're never going to launch a human without a life support system. So, and being the best at that is what we've done. That's what our mission and vision has been for 32 years. How has it changed? I mean, everywhere. You know, when I had dinner with Elon in 2002, and he had PayPal money, he was trying to figure out what to do with it. And we were designing a greenhouse to go to Mars with him when he got pissed at the launch industry. And so worked at the ground at starting SpaceX and teaching Elon what a PDR and a CDR was, which he did not know at the time. The money has come in. What I've seen is a lot of, you know, commercial enterprises starting up with big dreams, knowing, you know, quoting that they're going to have a space station flying for, you know, less than $1 billion when the one we have out there costs us $130 billion, and a lot of unrealism in that regard. My biggest BD problem is not whether a new business will start, it's when it will start. You know, there's a lot of promises out there. But, you know, from an innovation standpoint, our biggest problem, frankly, is that the big guys don't care about IP. I hate to tell you this. I'm one of the experts on IP in space, and I constantly telling the IP lawyers at NASA not to give my technology to some other company, that's not how it works. You know, especially with small business innovative research, we have special IP rights, and that is a real tough thing. I am battling. I was on email and phone with IP rights just yesterday with NASA and stuff, and it's a real problem. And I'd love to talk to the space lawyer here because I want to know if the Taylor Act of 1870 is still in force, which is that if a big company screws over a small company in the course of doing business with the government, that the government has to pay for discovery. And I've had to invoke that twice so far. So anyway, that's
So let me
a rambling
open it
answer.
up to some of the other panelists. What are the biggest challenges you think the space sector faces, and what can we do to address those?
This kind of goes to a point that I've been trying to make, which is I think that we're not utilizing the semiconductor industry enough in what we're trying to do. I mean, the general was saying earlier that we're competing with Alabama and Colorado and Florida and California. California is a whole different ball game there, so I'm not going to worry about that. But Alabama and Colorado don't have the semiconductor industry we've got here, not even close. And so we've got to figure out a way to bridge that gap and get the semiconductor groups. And we're talking TSMC, we're talking Intel, we're talking Microchip, we're talking ON. I mean, there's a lot of companies making chips here, and we've got to figure out a way to have them working with your company, you know, Boeing's, Raytheon's, you know, people who are sending stuff up, and then go all the way up to NASA and those types of groups. We're just not leveraging that enough.
Okay, anyone else?
I can't add much to that. I totally agree with Hugh. The opportunity for this, the base that we have in Arizona of semiconductor industry and the need to deeply understand what a range of industries, and then specifically to space and the specialized environments you have to go into, the specialized testing you have to have, how do you use some of the technologies in new ways. The only way you do that is in deep conversations with companies in those industries. And then how do you go solve them? And then how do you use the capabilities that we've been building up in the state of Arizona for the semiconductor industry, the microfabs, the advanced package technology, et cetera. We have it all here.
Okay, for Hugh, the semiconductor industry is facing challenges related to workforce development, and there's a projected shortfall of 67,000 semiconductor workers in the U.S. by 2030. How can Arizona space and semiconductor industries collaborate to address this issue, and what role can universities play in developing this talent pool?
Yeah, I want to make sure everybody understands. You keep hearing this stuff about there being this shortfall of engineers. That's a relatively speaking a long-term problem. We're having problems getting our students hired right now, and that's just a fact. I mean, I've had students, amazing students, and this is across the board. This isn't only ASU or U of A. This is across the United States. The companies are not hiring, and that's a short term because they're looking at the short-term thing is my guess. But you're going to lose out on these really high-quality students right now if you don't get serious about, figure it out, get these folks hired, maybe utilize the internship stuff. But that's a fact. I mean, so there's a short-term problem right now. These students are not getting hired. So I hear this thing about, oh, there's going to be a shortfall, but people are not filling it up right now, and that's a serious problem. We have right now, and ASU is one of the best places because we're huge. Like there are 32,000 engineering students at Arizona State University. 32,000. That is a huge workforce that is available right now. And we have workforce development programs. We are engaging with some companies. TSMC, we have a JDP program. I actually, one of the students that didn't get hired but is going to be working at Intel as an intern, so that's great. That keeps them in a PhD program. There still is a disconnect between what the industry's, what I would consider, I don't think they're taking advantage of the workforce that exists today. And there are several DoD-sponsored programs that are in workforce development that are working pretty well. One of them is SCALE, which is a really good program. I'll encourage you to take a look at that. It's actually out of Purdue. But there's several other types. I know there's one that's out of U of A right now. And they provide funds for undergraduates to get engaged, and then a lot of them become graduate students. And this is going to be my last point here. There are 3 levels to what the industry needs to hire. There's the technologists, which could be associate's degree level, okay, and that's a big one. We don't really supply that at the university level, but we have excellent community colleges which can produce that. And then you've got your bachelor's degrees and your engineers and scientists who supply that. We have a lot of those. And then, of course, we have our graduate students who eventually become your subject matter experts, your master's degree. So there's all these levels. I think we've got the talent. They're just not getting hired. And so we need to really think about this. You hear about the shortfall, but we're not making that connection right now, and it really needs to be solved now.
Sure.
Yeah, I've got to be very careful here. By the way, I am not an anti-next generation. I don't know what it's called, Gen Y, Gen Z, Gen whatever. I hate those generalizations. What we have found at Paragon, our best way of finding good talent is to sponsor like senior design projects and stuff like that, because you get to test drive the student. Because I'm going to know if I'm going to make it out here alive. The degree doesn't tell you whether they can work. It's a great thing to have. They got a certain amount of education. I often say the 2 things that will get you an interview at Paragon is if you grew up on a farm or if you went to a military technical school. Because no farm kid ever went into their parents and said, I can't milk the cows today because the milk machine's broken. You freaking you fix the milk machine. It's that hands-on stuff. And one of the things I've seen going out, and this goes all the way down to the high school level too, and they've taken shop class out. People don't build stuff. You can learn all the theory in the world, but if you don't get your hands dirty, however it is, you don't understand it. And so that's one thing we'd like to see a lot more from the education side. I remember I was on the Dean's Advisory Board for the College of Engineering, and they said, yeah, we were going to get rid of the shop down at U of A. And I said, you do that and I'll never, ever hire an engineer from you guys again. And so I'm pretty adamant about that. You got to come in, you got to have somebody who has a work ethic that comes in, and you can't measure that by a degree. So it's good to test drive them, and we use the programs to do it.
And I encourage you to come and schedule a time, and we'll walk you around our campus and what we're doing. I mean, we have, trust me, I try to kick their butt all day long. I mean, I really do. And I tell them, you think I'm bad? Go work for a CEO that they're really going to grill you. So you better get ready to work. And so, but I encourage anybody who wants to come onto the campus and see what we've got going on.
You'll be glad you put me in between them, huh?
Yeah.
Let me take that alley-oop because I'll start by saying that the workforce problem is a global one, right? It's not an Arizona exclusive one, but in Arizona we are better positioned than most other states at addressing that. And as Grant is talking about, you know, a lot of it. There's different levels. You need technicians, you need the subject matter experts, as Hugh said, and so. Tying it to the space industry, what can the space industry do? A lot of these started, some of the programs that we have here started from us bringing together task force of industry, and Intel's such a great partner because every single time we ask anybody from Intel to come down and say, all right, you know, because the Intel name will be here, it'll bring other industry partners to the table as well. And they do that, and so they tell us, well, you know, we need this kind of technician and this kind of technician that doesn't necessarily need a 4-year degree, but they need to be able to hands-on work into the lab. And so because of that, we have Future 48 workforce accelerators, right? And this is tapping into a different workforce that is not probably historically been in the semiconductor sector, that hasn't studied in the semiconductor sector, but that also introduces apprenticeship programs. So since the launch of our first workforce accelerator in Coolidge, we've graduated more than 2,400 students in that. That one stemmed from when Lucid first came here, and we had a very little knowledge in the state of how to manufacture electric vehicles. And so we needed to come up with something that can get them the workforce faster. So partnerships like that meant Lucid could put a vehicle into the hands of the students, they could work hands-on, and by the time they graduated, they would have worked on a Lucid already and be ready to go. So over the last few years, again, in partnership with industry, because it usually takes an industry partner to begin this, and community colleges, we launched the Future 48 accelerators in Coolidge, Yuma, Kingman, Phoenix, Apache Junction, and Mesa, and there's more on the way. So it was a total commitment of about $30 million from the state. But again, industry really, we leveraged that to make sure we maximize that from industry. So to Hugh's point, there's over 43,000 engineering students enrolled right now in Arizona. He said the ASU number, so you know the rest come from U of A and AU. But you know, again, these are people that where ASU, we're so privileged to have ASU, U of A, and AU that say, hey, well, if this is what industry needs, let us adjust the curriculum. There's many universities in the country that will not do that. They'll say, no, this is our curriculum, this is what we teach. And so people graduate to Grant's point, they graduate and they might not be ready to jump in, right? Because they're not being prepared for that workforce. Here in Arizona, that's different. ASU, U of A, every single community college, Maricopa Community College, Pima Community College, when we bring these task force together, everybody's there. They're all at the table and willing to listen and adjust quickly. And if the space industry can do something like that, where it says, this is what we need, this is the kind of talent that we need, and this kind of person is going to be ready to take us to the next level, you'll be surprised at how many open doors and willingness to collaborate you get here in Arizona.
Thank you.
Really short comment. One engineering thing, ban PowerPoint from engineering. Okay, power corrupts, PowerPoint corrupts, absolutely. Just get rid of the PowerPoint. We do not want engineers who know PowerPoint, period. And in fact, it harms their ability to do real work, just so you know.
With that, why don't we open it up to a few questions from the audience? Steve.
Yeah, I want to.
Mike.
Thank you. I want to address Hugh's concerns about the lack of hiring at the moment. So, over the last 2 years, there's been a lot of macroeconomic headwinds. And when there are headwinds, what happens is companies hunker down. They quit investing and they quit hiring. There continues to be a massive demand for talent. In the last 2 months, we have more uncertainty than the world has ever seen. And as a consequence of that, the hiring is going to come to a halt. And in addition to that, because of all the reduction in government jobs, a lot of contractors are going to lose their contracts as well. So we're going to go through a very tough time, I believe. Tariffs are going to have another deleterious impact on our economy and on our companies. And So it's really these macroeconomic forces that are preventing companies from hiring as they would want to if they knew more about what the future might hold. That's the issue that we're facing as a state, as a country, and to some extent the world.
I'm aware of that. But we also have to understand the risks. I realize that the companies can't hire right now. Internships are actually going to probably be the key to try to bridge that. You can also probably leverage the national labs and some of the, especially the DoD groups, because they probably will be able to weather the storm. I mean, the general was saying that it was an $80 billion 8% cut, but Space Force was only a 1% cut. So in the work that we're doing, a lot of the work that we're doing in EE, it would be Space Force related. So we can leverage keeping them engaged through the DoD and the DOE labs. That's a possibility. But we have to be super creative about this, because you're going to lose these folks, because they're going to go off and they're going to go and they're going to work in they're going to work for Chick-fil-A. I'm not kidding. That's what they'll do. They'll disappear, poof. And so all that work that we've done. So I'm aware of the problem, but we have to get serious about finding ways to bridge them. Now, like Intel has this program. Well, they do lots of internships, and perhaps you guys do too. That's helpful, but we're going to have to get kind of creative about this to keep those students moving forward.
Okay, other questions? Yes.
Thanks. Hey, Jason Yoakum, been involved with AZ Tech Council and work with Viasat here locally. Sort of tying back to the previous conversation that we had associated with the space policy and the roadmap, one of the things I noticed with in particular the semiconductor industry is there's a lot of sub-industries that take advantage of these opportunities that are coming into Arizona. And independent of the growth of our workforce and all of that, I know there's a lot of conversation around that, but fundamentally what we're bringing into Arizona and how we can leverage that, I think it's really important for us to think about how we can leverage that from a roadmap perspective. What are we trying to accomplish here in Arizona, and how are each of these subcategories going to take advantage of these different synergies that are out there? And rather than leveraging, individual, growth for people, how do we think about that in terms of the technology that we're bringing in, and does that really satisfy what we're trying to do in Arizona? And I think in particular, especially with the investment that's coming into Arizona associated with semiconductor, there's so many categories of that. And are we thinking about that at a state level? Are we thinking about that from a roadmap, a policy level, and not necessarily ASU-wide, but just as a state?
Yeah, so that's one of the things that part of the National Semiconductor Economic Roadmap was highlighting, again, where are the strengths, right? We don't pretend that Arizona can cover the entire supply chain or life cycle of the semiconductor, although we will try. But what our big focus was on to leverage the long history of Motorola, Intel, NXP here, and double down on the manufacturing piece. Again, back to the sexy headlines of the TSMC's $100 billion and Intel's doubling down on their investment. Those conversations started in 2013, right? 2012, of really showing these companies why it makes sense to invest here and what we were willing to do with them. Again, and because there was a clear roadmap at that time. We said, we want manufacturing here. In order to do that, we're committed to bringing your suppliers here with you. And so part of the announcements that you don't see a whole lot less of is the 40-plus suppliers that have come here following TSMC since 2020, right? And they're spread out throughout the valley, so the economic impact is there. There's chemical suppliers down in Casa Grande, Peoria, Chandler, everywhere from there is going to benefit, right? And then now we get to the next level. Okay, Amcor is setting up a $2 billion shop for advanced packaging. So now we've taken a semiconductor that can be assembled and manufactured at TSMC, drive it down to Amcor for testing and packaging. ASM is going to be setting up their OSAT in Scottsdale, right? That you just reduced 4 trips around the world, even though we're still at a point where it has to do 50 more. But again, just reducing that is pennies add up to millions of dollars in savings. And again, we were very clear on what we wanted was manufacturing to bring that to build a resilient economic economy here to Arizona to avoid what happened in 2008, which is what created the big pivot. And because of that, now we're in a privileged position we've done such a great job there as a state with all of our partners that now we can shift to R&D. How can we leverage this to really bring R&D here? So it's the chicken and egg scenario where do you go R&D first to innovate, or do you go manufacturing first? And then when you go to a plug-and-play event and you talk to some of the people that are starting up new businesses, half of the time they're like, well, yeah, I'm from Intel. I used to work at Intel. Right? So the manufacturing creates these next level thinkings so the next big wave of companies that are starting are here, not necessarily concentrated in Silicon Valley or where the design is happening. Now we're going to bring design here, and the next EDA and all that, the next big breakthrough to come out of Arizona, which started with us really focused on the manufacturing piece.
Yeah, Michael, I'm sorry to kind of highlight on that. One of the reasons for my question is exactly what you brought up, is there's this tremendous ecosystem in Arizona, and not just an ecosystem, but it leverages a global, like, what is Arizona all about and what we're doing here? And I think these types of infrastructures spawn all sorts of innovations, and that's one of the things that I'm really intrigued about with the new Arizona Space Commission, with the AZB, the Tech Council, and some of these other space organizations that are really trying to build this infrastructure. You know, we're all companies that are trying to make money at the end of the day, but at the end of the day, if we're touting and advocating for what the technology is, it's going to help us all grow, and I think that's really, really important. So the more we can push that forward in events like this, but further at a policy level, it will only help us. So I would just suggest that as we think about that, let's continue to push that forward in terms of our ecosystem and our roadmap for Arizona.
Thank you. Well, time for one more question. Quick, yes. Sorry, a quick question and quick answer.
The quick one is simply bringing this back to semiconductor synergies with space. You've talked about how you have a core industry here. You've talked about how you want to have a core industry around space. How can space help the semiconductor industry in terms of advancing R&D and tech? And how does that conversation that the two of you talked about need to happen between the semiconductor industry and the space industry to help the semiconductor industry learn what space needs for the next 10 to 20 years?
So I'm going to respect Jessica's quick. It really is the companies across the industry is going to deep conversations. That's actually how we built our edge business at Intel, across a range of industry. You have to go into deep conversations, understand what the application is, what are the specifics. So it's opening up those conversations across the many companies we have in the Valley. I don't mean to offend Tucson and all the other, but there's a lot of semiconductors companies here in the Valley, and having those deep conversations. That's how we help each other. And we can use the communities that already exist, whether it's Arizona Tech Council is one of my favorites. It's where all the tech industries come together, and it's an opportunity for that. And then I know the space communities are being built up here.
Okay, I'd like to thank the panel.